NXP and I'm here at ARMTechCon 2015 and I'm joined by Ian Morris at the NXP booth, and Ian's going to demonstrate the latest innovations from NXP. Okay,
great.
Ian.
Thanks, Patrick. So we're today at ARMTechCon, we're introducing our new wireless microcontroller, the latest in a long line of wireless microcontrollers from NXP. This one includes a Cortex M3 microcontroller, along with a IEEE 802.15.4 radio operating at 2.4 gigahertz. So the microcontroller itself contains a lot of interesting features. It's got embedded flash, RAM, and EEPROM. It's got a whole host of peripherals, ADCs, DIO, timers, PWM generators, etc. In addition, we support the onboard MPU, or memory protection unit, as well as a DC-DC converter to reduce the cost of the architecture of smart light bulbs down from 3 chips to 2 chips. So the MPU is a really important part for security reasons. Okay? So what we do is, the memory protection unit allows us to run software in sandboxes. Okay, so that means your application can run in an area of memory and not have access to other areas of memory or peripherals. So potentially a rogue application could get into there, but it can't access software security algorithms or encryption keys.
Gotcha,
okay. So the DC-DC converter is a really useful functionality for smart light bulbs. So the classical architecture of a smart light bulb, a Zigbee or a thread-connected light bulb, is a 3-chip solution. An LED driver chip, an AC-DC power supply, and obviously the wireless microcontroller.
Right.
So what we can do with our internal DC-DC, we can reduce that down to a 2-chip solution. So we can eliminate the AC-DC power supply by taking the high voltage DC from the LED driver string, putting it into our DC-DC and running our chip from there. So we can go from 3-chip solution to a 2-chip solution for a smart light bulb.
How does it handle security? Because that's such an important part of ARMTechCon this
Absolutely.
year.
So this chip is actually running embed software. Okay, so it's working with Mbed's IoT device platform. So the chip here is running Mbed OS, which is a single-threaded event-driven OS. And it's communicating using the Thread communications protocol. Okay, now Thread encrypts all data that's being transferred over the network using an AES 128-bit key. Okay, but that key needs to be stored very securely, because what a lot of people don't realize is that when they discard my Thread or my Zigbee-based device after its end of its life, it contains the key to my network. Okay, so I have to be really careful. An attacker, a sophisticated attacker, could take that device, read my key out, and potentially access my network. So NXP can offer, in addition to this device, secure element technology that we use in chip and pin cards, that we use in e-government passports. We can embed that into IoT devices, such as light bulbs, such as switches, etc., and that will securely store the key that's used to communicate on the network. So then if a user went to discard their device at the end of life, it's very, very, very difficult for the attacker to then get that key out, because this is banking grade security.
Absolutely, yeah.
Okay.
That's interesting, okay. Nice twist. Is that an NXP feature, secure, that secure element?
Absolutely, that's a current NXP technology, secure element technology. Yep, absolutely.
Okay. And are you bringing that from some other applications that you've had?
Yes.
Some other devices? Are you scaling it down to IoT type devices?
Exactly, and that comes from our history in the banking industry. We're one of the leading suppliers to e-government. I think we supply 70 to 80% of the e-passports. Okay, the chips into there. We're a massive supplier into the banking industry for chip and PIN cards.
So you have a history in that. You've got that historical
expertise. Exactly. Leveraging that into the IoT space, because we see a great need to secure devices that are going to be part of the Internet of Things, and we can bring our technology to bear on these lower cost, lower memory footprint devices that aren't as sophisticated.
Did you have like a reference kit currently? Or?
Yeah, absolutely. So what we do have at the moment is we have a 802.15.4 base kit that also integrates NFC technology. Okay, and that's another piece to the security puzzle, because not only do you want to store the keys very securely using secure elements, so they're protected throughout their life, you have to get those keys into the device when you first add it onto your network. And that's where there's a lot of holes in the communication protocols. What we can do is use NFC technology to allow us, when a consumer buys a device, brings it home, they can simply tap it on the gateway, and via NFC, or near-field communication technology, the key is transferred from the gateway, where it's stored securely, into this device, using this short-range communication. It's very difficult to sniff, and then gets stored securely in secure element. So we can control the whole life cycle.
You make it very secure from the end node right through the system.
Absolutely. So NFC commissioning to get the key in, secure element to store it through its life, and then secure element to protect it after it's been decommissioned.
Nice touch. Good job. Okay, thanks Ian for your time. Appreciate
Okay.
it. Good job.
Thanks.